Good morning, everyone. To provide you with a brief introduction and an overview of some of the research developments that have given rise to these large language models, and more specifically, the ChatGPT model that we're here to discuss today. Now, this field of research is known as natural language processing, or NLP for short, language technology. And it deals with the automated processing of language data, whether that be text or speech or spoken data. So very broadly speaking, it's about developing systems that can make sense of human language. And there are numerous application areas for these systems, such as machine translation, information retrieval or search, sentiment analysis, which deals with the automated detection of opinions in text, information extraction, which deals with extraction of factual, structured information from text, and question answering, or more broadly speaking, dialogue systems would deal with the conversations with automated systems. Now, the dominating methodology within the field of NLP, as in most AI or data science fields in current day, is that of deep learning or neural networks. So neural networks are applied to all NLP tasks and has shown great success on a number of NLP benchmarks in recent years. So the reason for this success of neural networks in NLP has been brought about maybe by broadly speaking, two developments. The first is the availability of very large amounts of language data. So consider, for instance, all the textual content of the internet, all the digitized books and documents that are available in principle for natural language processing. This, in combination with the substantial increase of computing power and specialized processing units that enable parallelization of machine learning training, in combination, this has brought about the development that we're here to discuss today, which is the training of these large language models. Now, in NLP, the word or the term language model has a fairly specialized meaning. So it's not just any model dealing with language, but it's a model that, given raw text as input, is trained to predict the next word in a sentence. So for the example here, for the sentence, a robot must, the language model is then trained to predict the next word, so say exterminate, and if this is not in accordance with the training data, the textual data that the model is trained on, it was in fact obey, then an error is calculated and the model is updated. And this model updating is part of the training procedure of these models and is repeated millions of times during training. So when we have a trained model that has been trained on large amounts of language data, we typically make use of this language model as a first step in creating NLP systems. So this will provide us with good representations of language, and this is what these models have been widely used for in research. NLP research, they've been used as representation learners. So they give us good numerical representations of language, which is symbolic in essence. So a language model is then typically fed into a classifier that is tuned or trained to perform a specific task, such as sentiment analysis in this case, that is predicting whether a sentence is positive or negative. Now, the widespread use of language models as representation learners has given rise to sharp improvements overall NLP tasks in our field. However, there's another capability of these models that have maybe received more attention in the media in society at large, which is the use of these language models for text generation. So given an input, a prompt, it's often called, and a language model such as GPT-3 will then produce a textual output. So more specifically, these models all make use of the transformer architecture that you can hear more about later today if you're interested. But basically, a numeric representation of the input will then be fed into these stacks of transformer decoder modules that will produce words one at a time, and according to which words are most probable continuations of the preceding sequence. Now, one thing to note about these language models, as I've hinted at already, is that they are very large, and there's been a development in the field in recent years where the number of parameters for these models are steadily increased for every year. So as you can see, we started out in 2018 with the ELMA model, which was arguably the first large-scale language model. The GPT-3 model here has, as you can see, 175 billion parameters and is trained on billions of words in textual content. It is not the largest language model, but there's been, as you can see, a steady increase of in terms of size of these models. The reason for that is also has been shown in recent research, is that this scaling up actually leads to what has been termed emergent properties. So it has been shown for several NLP tasks, such as natural language understanding, the prediction of words and context, that when scaling up to a sufficient size, the properties of these models can no longer really be extrapolated from the smaller models. So you can see here this very sharp increase in performance or accuracy of these models in terms of a number of NLP capabilities. So it's against this backdrop that the ChatGPT model was released in November last year via web demo, as I'm sure you're all familiar with. It's important to note, however, that this model is not available for download. There is no scientific publication that describes it. There are some blog posts. And really the details regarding the specific training data, the time and energy consumption that went into the training of this model is unknown. But what we do know is that the ChatGPT model builds on the GPT-3 model that I've already mentioned. However, this model was known, and many of the other large-scale language models are known for producing problematic content, so biased, racist, sexist language, as you'll hear more about later today. So what is new really with the ChatGPT model is the widespread use of human in the loop. So there's a large amount of human manual labor that has gone into actually moderating and training this model. So both in terms of constructing dialogue data for the training of the model to increase the dialogue capabilities, ranking of outputs from the model, and then retraining the model. And this extent of human training that has gone on is really unknown. The extent to which as I said, there's also been very limited evaluation of the model. However, earlier this month, one of the first research papers that actually evaluate the model have been released, showing that the model ChatGPT has strong zero-shot capabilities, meaning that it can excel at a number of tasks which it was not explicitly trained for. That being said, it also has clear limitations. For instance, for low resource languages, It has lacking in several types of reasoning, and it is also prone to hallucination of actually making up facts. So against this backdrop, I'm really looking forward to the program today, where we'll talk more about both possibilities and use cases, risks of these models, and also increasing our knowledge of the technical underpinnings of these models. So with that being said, thank you and welcome.